Hey, what's happening, folks? This is a demo, I guess? I don't know. So I'm on vacation, and like an idiot, I'm like, you know what would be fun? Make a MetaSound node. Like I don't have enough of that in my non-vacation time. But yeah, I've been wanting, this is something that I've been wanting for a while. And I was, I was just thinking the other day, and I was like, hey, you know what? I bet I could actually just make that myself. Which is kind of the fun of this whole thing, is like being able to make stuff yourself. And it's a stutter effect, right? So I've shown in the past, like how you can do, like a really basic stutter effect with like just looping a wave file. But this is like an actual audio effect, kind of like a looper pedal, right? And so I thought that'd be fun to show off. And then I kind of got carried away, as you do with MetaSounds, and I made this whole procedural music patch, which I thought could be kind of fun to walk through a little bit here. So first I start out with these drums, and I've got six drum bars of drum pattern, and they're pretty much the same. It's the same pattern, but with like little different ghost notes and flares and stuff like that. So for different variations, and then every bar I just select a new one, and I play that. I don't loop any of them. I just keep playing. The next one is basically like a big playlist, and I just randomly select from that playlist. And then so here's actually let me turn it down real quick. Yeah. So I I basically have this wave shaper, just kind of drive the drum. And then it goes to this cool delay fill effect that I thought that I made. I was like, oh, this is kind of fun. And the way that this fill effect works is basically we've got a little quarter note counter. So I've got this beat counter and 16 beats. So at 4/4, this is a 4-bar cycle. And every time I hit beat 14 in the cycle, which is the second beat on bar 4, I activate this envelope generator. And the envelope generator basically mutes the drum audio and manages the switches from a dry pass-through of the stereo delay to a wet level version of the stereo delay. And the last thing to sort of pass into the delay, because I have this slower attack, this 1/10 of a second attack, is a little bit of that drum hit on that backbeat. And then I randomly select some musical timing for the delay. And I get anywhere between, I guess it looks like anywhere between quarter note to 16th note. And then I get this interesting sort of fill that's different every time. And it's not like it's delay based basically, which is kind of fun. But then I was like, hey, this is still audio files, and I thought it'd be, to really show this, I would want to be able to mix in stuff, mix different elements, and then also mix in maybe synth elements. So I've got this synth bass pattern. And the way the pattern works is, you've kind of seen me do this before, but basically I have like an 8th note pulse, and then I have a 16 count cycle. So eighth notes over 16 counts is 2 bars, so it's a 2-bar cycle. So the pattern's a 2-bar cycle, and then I have a random pitch selection and a random rhythm system. And the random rhythm is really simple. It's just 50-50%, 50-50 probability. And then the pitch selection is from this minor Dorian scale. And then I have custom weights for the different scale degrees. So for the first, third, and fifth scale degree, those kind of have the higher probabilities, and then the sort of 50-50% on the second scale degree, and then 7th, 6th, and 4th scale degrees are much less probable. So what you get is, pitches that are plausible bass lines. Okay? And because it's seeded randomization, the cycle resets, and so you get a random cycle every time. Yeah, so and then it's going into the synth bass. The synth bass is driven by these AD envelopes that have like a sort of sharp decay, a quarter note decay. So you get this sort of plucky bass sound. And it's 2 saw waves, 1 octave apart, so you get this sort of bass reinforcement on this lower octave, passing into a wave shaper. And the wave shaper, you kind of see, we get these ramps, these sort of gentle ramps getting summed into this wave shaper. And the wave shaper is pushing the value, but sort of soft clipping it. And so you can kind of see what's happening is the ramp is getting sort of curved off at the clip at the edges, at the output edge. And then the result is you get this sort of odd quarter harmonic push. So it ends up squaring it off a little bit, but not too much. And then that is all going into a ladder filter. And the ladder filter is being modulated by the cutoff is being modulated by the AD envelope. So that's part of the plucky sound. But then also I have the resonance of the ladder filter being modulated by this LFO. And the LFO is on a 1-bar cycle with saw up ramp. And so what happens is the resonance over the single bar goes up every bar. And that creates a certain kind of effect where, if you remember with ladder filters, when the resonance goes up, the feedback at the cutoff results in scooping out some of the low end to the low pass frequencies that pass through. And so what you get is is at the beginning of the bar you get more of a low end oomph coming through, which feels more like a downbeat, and then at the end of the bar it's all scooped away. And so you get this nice motion every bar, but then you also get this very sort of implied phrasing that regardless of whatever the notes that the bass is playing, it always feels like there's this sort of bar cycle phrasing that's happening. So it makes this sort of musical consistency. Anyway, this is all getting passed into my custom stutter notes. This is custom stutter notes that I made. And the way that they work is they use what's called a circular buffer. And the circular buffer, if you imagine like a normal buffer, which is like, if you lined up all your samples in a row from left to right, you would write from left to right and you would read from left to right. A circular buffer is, if you could imagine those, but like sort of set up in a ring. It's conceptually in a ring. And so conceptually, if you imagine it as a ring, and then you write into it, but it's like you just keep writing, almost like it's a loop. Like you write a loop, and then you can read a loop, and the read and write are different indices. So usually what happens is the writes in a sort of along the circle path, and then the read can actually bounce around wherever it wants to bounce around, which is kind of cool. And so in my case, because I'm looking for this sort of stutter effect, what happens is the audio in and the audio out are basically reading and writing at the same sample. They are writing into the buffer, and I'm reading off of the buffer, but they are synchronous. And then what happens is when I start the stutter effect, the read starts at wherever the write is currently, and it sets a little marker, which I call the start index, and then it treats that spot as like the start of the read back. And then basically the max stutter duration is the size of that ring, so however long that ring is, the sort of circumference of the ring, if you can imagine. And then the stutter division is how far along the ring I read before I start at the beginning again. And so when this is 1, it reads the whole thing. It divides the value by 1, so it's the whole duration, and it just loops. And if this gets set to 2, then it goes halfway through the ring and then starts over. Halfway through the ring and starts over. And then, if it's third, then it's a third, and whatever. So whatever value is here is divided by that. And so this way I can kind of create like these sort of interesting rhythmic stutter loops. And the right buffer has a special feature where it conceptually, wherever the start point was when I hit start, it will write all the way until the end of that loop, and then while it's active, while the stutter effect is active, it will stop writing at that spot. And so what that means is you end up getting this sort of sample that gets looped. And then when I stop, it resumes writing. So that's how it works. And then you can see here I have set here. We can do like this. We can set the max stutter duration to whatever notational value. So let's do this. Let's set it to a half note long, so it's kind of short. And then we'll set this to 0, and I'm using musical math here. So 2 to the power of, and so when 2 to the power of 0 is 1, so this will output 1. And then when this is over 1, see, I'm quantizing it to integer with the integer conversion. This floors it. So this basically rounds down. So when this is between 1 and 2, it'll round down. It'll be 1. So 2 to the 1 is 2, so it'll output 2. And then when this is above 2, it'll be 2 to the 2. 2 to the 2 is 4. And then 2 to the 3 is 8. And 2 to the 4 is 16. And 2 to the 5 is 32. And 2 to the 6 is 64. And then 128 and 256. And this, since it's all on a half note, so we're subdividing a half note, that means we're going up to 512. I don't know. We'll see if I am able to go that high. I actually haven't tested 512s. I think we're getting pretty small there. So then if I hit play, and then here you can see on this trigger once, I'm using these trigger once to gate the start and stop. That just ensures that the stutter effect starts and stops on a sort of musical rhythm. So instead of starting exactly when I hit start, it will start on the next half note pulse. Okay, so there we are. So now we're listening to the output of our stutter effect. We're no longer listening to the input of our stutter effect. And it's only a half note long, so we've gone through the whole loop, and the buffer stopped writing, and so now we're just reading in a loop. And if we go up to, now we can subdivide it. Now we've got half that. So we're at quarter note, eighth note, 16th note, 32nd note, 64th note, 128th note, 256th note, 512th note. You're barely hearing any of the audio at this stage. We're just like hearing any transient that's punching through in that buffer. Anyway, what's cool is that generally speaking, the subdivision will maintain the way that I've written the read system. Is it should maintain phase for the most part. There might be some drift because of just rounding errors. But yeah, so that's basically how it works. So you've seen the node. Let's take a look at the code. Rhyming. By the way, if you're interested in making your own MetaSound nodes, there's a really great tutorial by Anna Lantz, and she covers. It's a very basic node. It's just like a float multiply node. But if you add her tutorial to Aaron's Doppler delay tutorial, between the two of them, and then looking at other MetaSound nodes, you should be able to get the gist of making your own MetaSound nodes, kind of anything you want, anything you think you got an idea for. So I encourage you to try it out. But here's the stutter buffer sort of object. And I initialize and then set stutter and blah, blah, blah. And so here, what's interesting, so this is basically a circular buffer, except with one exception, is that the read index is not like a normal read index, because I have this read start index and read range. And so what I do is when you start, I set the read start index wherever the write index is currently. And then I set the read index to 0. And then I set my state. And so what happens is when I'm writing a sample, I write the sample and then I read the sample. That's kind of the process. When I write the sample, essentially I check to see if I should mark the buffer full. So the write index is circling around the buffer, and then if it comes back to the start point, then I have to count it as full, and that will stop. If I'm stuttering, if I'm the stutter effect and my buffer is full, then I will not write into the buffer. I will stop, because it's basically I've got my full sample. My sample is full. And then, but until then, it writes into the buffer like normal. And then if I'm not stuttering, it just keeps writing. So it just writes in the background, basically. Then when I'm reading, if I'm stuttering while reading, then I have the read index is basically off it's like a local start point. And it'll just read all the way to the read range. And I modulated the read range. And so it just cycles through the read range and then outputs what I consider sort of a local index based off of the read start point, the read start index, and the read range. So it's somewhere between those. If I'm not stuttering, then it's somewhere between the read start index and the full buffer size. So the range is basically full range. And then what I do is I take that read start index and I use that as an offset for the read index for the actual index that should be reading from, and then I read off that particular index. And so that's so it's pretty basic. And then there's really not a whole lot else to it. So I have the local cache of data. So here's my execute block. I just check to see if the subdivision has changed. If that's updated, then I update my params. I have a process block that precedes the start. A process block that has the start. So basically this handles whenever no triggers are happening. And then if there's a trigger subdivision of the block with start, then I have obviously a state change. So I hit start on the stutter processor, and then I process the block. And then the same, likewise with the stop, I reprocess the block. And then this just resets a bunch of parameters. This is something, oops, actually this should say reset trigger. Reset. This is copy pasta. And then if we look at my process block, I'm just getting the audio frame in and the audio out. I'm just like storing them in local pointers, and then I am writing. I'm reading from the sample and reading in from the input, and then writing to the output. That's super simple. So that's it. And then otherwise, it's just resetting parameters, reset internal and reset these sort of initialization sort of stuff. So that's my my stutter effect. I hope this was interesting for you. If you let me know if this is interesting. If you're interested in learning more about MetaSound code, I have like a sort of planned video, like a couple of videos on making a MetaSound node more explicitly. And so I hope that is of interest. I also, by the way, am working on my Unreal Audio Essentials presentation, for the sort of lengthy version. It's just taking a while. Partly because I just do it in like every once in a while during my downtime when I get some free time and I feel like working on it. But I'm also like writing a script and stuff like that, so I'm trying to make sure that it's not too, like, this video has gone on too long already, because I get rambly, so I'm trying to avoid that. Anyway, so that stuff's coming down the pipe. This is the YouTube, so subscribe if you dig it, like it if you dig it. I don't know, whatever. Do your YouTube thing, and yeah, I'll see you all on the flip side.